Yeah, hello. Good afternoon. Welcome back to Traffic Class. Yes, so I have five questions I want us to look at quickly. Within maybe 20 minutes, we should be done with the five questions because I'm going to explain. So the first question is we have to evaluate 3 log 2 plus 2 log 5 minus log 0.2. So this is one of the simplest question on the list today. We have to evaluate it. So quickly, we apply the laws of logarithm. This can be written as log 2 exponent 3 plus log 5 exponent 2. Then this is minus log 0.2. So we don't work on this, we can leave it like this for now. Now we look at this again. When we have logarithm and we are adding, we can multiply the numbers. So log 2 exponent 3 by 5 exponent 2 minus log 0.2. And then we know that 0.2 also has to do, the minus has to do with the division. And so this can also be written as log 2 exponent 3 times 5 exponent 2 divided by 0.2. And then this is going to give us 8 by 25 times. So this is going to change from division to multiplication. Or better still, we can still make it 0. So divided by 0.2, and then 0.2 is the same as 2 over 10, and so 2 over 10 now becomes 10 over 2. 2 here 1, 2 here 4, so we get this times this, that is going to be 40 by 25. Just a minute. Yeah, so we get 4 log, this is going to be 100 times 10, 1000. And so this is in base 10 actually. So this is going to be log 10 power 3 base 10, which is going to be 3 log 10 base 10. And then we know that when we have a log of a number to the same base, that is going to give us 1. So 3 times 1, which is equal to 3. So that is it for the first question. The second question also says that given that 5 on 4 all raised to the power x plus 6 is equal to 16 on 25 all raised to the power x, we have to find the value of x. And so this also has to do with indices, and so we apply the various properties of indices, trying to see if we can convert this to smaller number raised to another number. That is going to be 5 on 4 exponents x plus 6 is equal to 4 to the power 2 16, and so we see 4 here, so 4 to the power 2 all over 5 squared exponent x. From here, I see 2 common to 4 squared and then 5 squared, so that is going to be 4 on 5 exponent 2x. But this is 5 on 4, this is 4 on 5. I can reciprocate, and by reciprocation, the power changes to negative. And then from here, I compare the power since the bases are the same. And so from all indications, we see that x is equal to negative 2 for this question. When we do it like this, is the answer we get for x. We go to question 3, which also says that we should find the equation whose roots are minus 1 whole number 1 over 2 and then 2 whole number 1 over 2. And so we know this from the concept of quadratic equations, that in every quadratic equation is equal to x squared minus sum of roots alpha plus beta x, and then minus the product of roots alpha beta. Now we have the alpha as minus 1 on 2 and then minus 1 whole number 1 or 2, and then the beta as 2 whole number 1 or 2. So we find the sum of roots. So the sum of root alpha plus beta, this is minus 3 on 2 plus 5 on 2, which now gives us 2 on 2, wow, which is equal to 1. And then alpha beta minus 3 on 2 by 5 on 2, which is minus 15 on 4. Okay, so substitution x squared minus 1 of the x, this is going to be minus 15 on 4. So x squared minus x plus 15 on 4 is equal to 0. Multiply through by 4. 4x squared minus 4x plus 15 is equal to 0. So this is the quadratic equation with the roots as minus 1 whole number 1 over 2 and then 2 whole number 1 over 2. Quickly to question 4, which says that if log 3x minus 7 base 10 minus log 5 base 10 is equal to 1, then we are to find the value of x. So still concept of logarithm applied here. This is minus, and so we can divide this by the 5 log to the base 10 3x minus 7 all over 5 is equal to 1. From here we go back to the concept of indices. It is from indices that we get logarithm. So if we have a concept of this nature, it is going to be the number standing alone is equal to the base raised to the power the number on the right hand side. And so what I'm trying to say is that this is going to be 3x minus 7 all over 5, giving us 10 exponent 1. It is just like having log 8 base 2 is equal to 3. Then we conclude that 8 is equal to 2 raised to the power 3. So from here 3x minus 7, 5, 10, 3x minus 7, 50, 3x is equal to 50 minus 7, 3x is equal to 43. Wow. Okay, so this is what we have now. And so we divide through by x. Let me confirm if the question is right. Okay, the question is right. And so 3, 10, 30, 3, 11, 33. So this cannot give us a whole number. There should be something wrong with the question, but I don't really know where the problem is coming from. Yeah, I don't really know where the problem is coming from, but let me check something. Yeah, so sorry, I've seen a mistake. So this is supposed to be plus, so 57, and then 3 goes into 57. I think 19 times, so 9 times 3, 27. 9, 3, 1, 3 plus this is 30. Wait, is it 27? 19. 19, so 27, 3, 1, 3 plus. Okay, so 3, 3, x is equal to 19. Alright, so question 1, question 2, question 3, question 4 all have been tackled. We go to the last question, which says that given that 5 raised to the power x, 5 raised to the power x plus another 5 raised to the power x is equal to 50. We are to find the value of x. So we just treat this as two separate terms. So let's assume we're to be having x plus x. We would have said that it is equal to 2x. And so the same concept, this is 1 here, another 1 here. So this is going to be 2 exponent. 2 times 5 exponent, x is equal to 50. Divide through by 2. Then 5 exponent, x is equal to 25. So from here, it is very clear that 5 exponent x is equal to 5 to the power 2. Therefore, x is equal to 2. Since the bases are the same, so therefore x is equal to 2. So 1, 2, 3, 4, 5 have been done in about less than 15 minutes. Thank you so much for your time, and then Enjoy the rest of your day. Bye.